Hello everyone and welcome to today's webinar titled Reference Materials, an Introduction to Quality Grade and an Overview on the Different Types of Food and Beverages. I'm Susie Valdez of LabRoots and I'll be your moderator for today's event. Today's educational web seminar is sponsored by Millipore Sigma. So let's get started. Before we begin, I want to remind everyone that this event is interactive and we encourage you to participate by submitting as many questions as you'd like during the presentation. To do so, simply type them into the Ask a Question box and click Send. We will answer as many questions as we have time for at the end of the presentation. If you have any trouble seeing or hearing this presentation, simply click on that Ask a Question box located on the far left of your screen. I now present today's speaker, Dr. Matthias Nold, a product manager for reference materials at Millipore Sigma. Matthias has worked at Millipore Sigma since 2016 with a special focus on reference materials for food and beverage tasting. For a complete biography on Dr. Matthias Nold, please visit the Biography tab at the top of your screen. Dr. Nold, you may now begin your presentation. Welcome, sir.
Thank you very much. I'm very pleased to have the opportunity to talk today about reference materials in food and beverage testing. Before I start, I have to point out that the life science business of Merck KGaA Darmstadt, Germany, operates as Millipore Sigma in the US and Canada. The presentation consists of a technical part introducing you to some general terms and definitions about reference materials, and an introduction about the different quality grades and certification methods. Then I will show you our range of reference materials suitable for F&B testing and explain you how you can find the products. And finally, I am going to show you some highlight product groups a bit more in detail. So let me start with a very basic question. What does testing actually mean? Well, testing, in the essence, is the comparison of an unknown sample with something known. And that something known is what we refer to as the reference material. This means that the quality of your reference materials is directly affecting the quality of your analytical result. As you can see here, there are many aspects of a product that can be tested. Testing can be qualitative or quantitative. Qualitative tests typically confirm the identification of an analyte or its presence or absence in a sample. Quantitative tests, for example, determine the actual amount of an analyte in a sample or the potency of a drug. Tests can focus either on the material itself, for example, its identity, chromatographic purity, content as mass percentage, or physical properties like melting point or viscosity. Other tests focus on the impurities present in a material, which can be water, residual solvents, organic or inorganic impurities. Each of these different aspects of testing require a specific reference material. Reference materials can be used in different formats in the testing laboratory, depending on product availability and method requirements. The three formats for reference materials are a neat form, usually as a powder or liquid, in solution or in matrix. Neat reference materials are typically available in a screw-top vial. They can be used to make stock or working solutions, often weighed and prepared daily or weekly. The advantage of using neat reference materials is the big flexibility for different applications, with larger material amount available. Also, many chemicals are more stable in powder form. On the other hand, there is an additional handling step required by the end user, which can bear challenges, especially if the material is hygroscopic, viscous or toxic. Depending on the skills, there can thus be a greater week-to-week variability of the resulting working solution. Reference materials in solution with certified concentration and stability will avoid these problems. These are very convenient to use and save a lot of preparation time, especially for calibration mixtures. On the other hand, you rely on the availability of a solution mix suitable for your need and have less flexibility. Matrix reference materials provide the analytes in a matrix similar to the sample analyzed. These are used to develop and validate test methods and to correct bias from the sample preparation step. Having certified matrix materials commercially available saves the time and effort to produce in-house matrix materials, for example by spiking with an analyte. But the number of available matrix materials is limited, so often there is no suitable product available. Also, the analytes are often less stable in a matrix, limiting the shelf life of these products. I would like to introduce some metrology terms now. A measurement is considered to be true if the mean of all individual measurements are close to the true value as shown in the example on the left side. However, the results here are widespread, meaning that the measurement is not precise and has a high uncertainty. The example on the right-hand side shows a precise test, with all individual results being close together. However, there is a bias in all these measurements, so as a consequence, this result is not accurate. For analytical results in general and reference materials in particular, we are aiming for accurate values, meaning that they are precise, so the reference materials should only have a small uncertainty contribution to the measurement, and also the value should reflect the true value. This can be achieved by assuring traceability. Metrological traceability is an important concept in the world of reference materials. It means that measurements can be meaningfully compared across different places, at different times, by different people, and using different equipment. The measurement result must hereby be related to a reference through a documented and unbroken chain of calibrations, tracing back to the SI unit of measurement. The International System of Units, or SI, defines the 7 units of measure as the basic set from which all other SI units can be derived. The two most common SI units of measure for traceability of reference materials are kilogram and mole, which we use in our reference material certification methods and certificates of analysis. Now, with this basic metrological concept in mind, let's take a look at the different types of reference materials. As this hierarchy pyramid shows, the level of certification and traceability requirements increases the higher you climb up in the pyramid. At the top level, we find the primary standards. The primary measurement standards are produced by national metrology institutes like NIST in the US or JRC in Europe. These authorized bodies are recognized by their national governments as the source of truth, considered to provide the highest level of accuracy and traceability in a reference standard. In the pharmaceutical world, you have primary compendial standards produced by the pharmacopoeias like USP in the US or the European Pharmacopoeia. While not necessarily a government entity, these pharmacopoeias work closely with government agencies and are legally recognized in many countries as providing the highest level of accurate and traceable reference standards for use in pharmaceutical monograph testing. Where national governments give standardization to the top level, specific ISO requirements provide standardization for the next two levels, certified reference material and reference material. These ISO requirements include 17034 and 17025, as well as Guide 31. Reference material producers must meet these ISO requirements to manufacture CRMs or RMs. Within ISO, CRMs are considered to provide the highest level of accuracy, uncertainty and traceability to an SI unit of measurement. RMs fall one level lower as they are manufactured and tested to a level less demanding. For both of these quality grades, certificates of analysis must be provided, and the information contained within is defined by ISO. Also note that while reference materials is a quality grade, it can also be used as a general term to encompass all quality grades within the pyramid. The quality requirements for the last two levels are defined by each individual vendor rather than by a national government or by ISO. For the analytical standard grade manufactured by our company, the product is manufactured within the general ISO 9001 quality system requirements, not specific to just reference materials. A certificate of analysis is provided with an analytical standard grade reference material. It contains information such as product identity, purity, and an expiration date. Generally, the level of certification varies from vendor to vendor. The lowest level is the research grade or research chemical. These may be well characterized, but are not designed for the use as reference materials and not considered analytical products. Let's take a deeper look at the differences among a CRM, RM, and the analytical standards grade. There are 4 quality attributes required for the property value of a CRM: stability, homogeneity across the lot, uncertainty, and traceability to the SI unit of measurement and to an NMI primary measurement standard if available. The RM quality requirements include just the stability and homogeneity attributes for the property value, but no traceability or uncertainty is required. Per ISO Guide 31, all information and data on CRM or RM quality attributes for the property value must be included in the certificate of analysis. For an analytical standard, there is no property value since the manufacturing and testing of the reference standard is not performed according to ISO requirements specific to reference materials. In the absence of a property value, the focus is on the material itself. Is the material sufficiently pure, stable and homogeneous? Is the material fit for its intended use? Since the C of A for analytical standards grades are not aligned to reference material specific ISO or compendial requirements, the information provided in them will vary from vendor to vendor. ISO quality requirements direct the manufacture, testing and documentation of CRMs and RMs. ISO 17034 accreditation means that an official body recognizes the producer's capability to manufacture CRMs. An ISO 17025 accreditation means that a laboratory is officially recognized to be competent in analytical testing. The accreditation documents provide guidance on how to manufacture a CRM, but only if a company has been successfully audited by an official accreditation body, it is authorized to manufacture CRMs. In addition, the ISO Guide 31 is intended to help producers to prepare clear and concise documentation to accompany a reference standard, such as the Certificate of Analysis. Note that our company globally has 4 different sites holding an ISO 17025 and ISO 17034 double accreditation to manufacture certified reference materials. ISO 17025 accreditation is also relevant for testing labs. One important note here: for accredited testing labs, the use of a CRM grade is mandatory if commercially available. The ISO and Pharma worlds have different definitions of traceability. Compendial and pharmaceutical regulatory guidelines do not require traceability to the SI units, but to a primary compendial standard. As CRMs, Merck's secondary standards have both types of traceability, thus providing greater accuracy for pharma monograph testing applications. And with that, we will look how all these requirements translate to the content of a certificate. Here is what information you find on a COFA of a certified reference material. Obviously, there has to be a certified value. This can be the concentration for a solution CRM or a mass fraction for a neat CRM. The value has to be reported with an uncertainty which is taking all the contribution factors into account, including stability and homogeneity of the material. There needs to be a statement about the traceability, mentioning the primary material tested against, which for example can be an IST SRM. The certificate should provide information about how the stability and homogeneity of the material has been determined. Then, the certificate would always state an expiry date. The certified value is guaranteed for the duration of the shelf life within the given uncertainty. This slide gives an overview of the different certificates of analysis for the different quality grades. It is quite apparent that as the level of certification increases, the amount of information required on the certificate increases as well. For more information, please refer to our new RM Quality webpage, which you can find on sigma-aldrich.com Quality Grades CRM. After introducing the different types of reference materials and formats, I'd now like to discuss how materials are certified, with focus on organic chemical compounds. Here are some of the best practices for certification of a reference standard. It's important that the material is well characterized for both identity and purity. The best approach for identity is clear identification by techniques such as NMR and mass spectrometry. Purity or potency does not include just chromatographic purity alone, but also residual solvents, water and trace inorganics from the manufacturing or purification process. All are required to obtain a complete picture of chromatographic and non-chromatographic impurities in the material. Mass balance uses multiple techniques to determine identity, purity and all trace impurities, whereas other approaches such as quantitative NMR and titration primarily use one technique. All approaches are useful for determination of purity or potency. We are focusing on mass balance, quantitative NMR, and isotope dilution mass spectrometry for organic molecules. We'll now take a closer look at quantitative NMR and mass balance. The concept of QNMR involves a high-precision weighing step of an internal standard and the sample of interest. After weighing both of these components into the same vial, a deuterated solvent is added and both substances are dissolved. Because only the ratio of analyte and internal standard is relevant for the calculation, the exact concentration of the solution is not important. After the NMR measurement, selected isolated signals of the sample and the internal standard are compared, which allows for the calculation of the mass fraction with a very high precision. Traceability is achieved by using, for example, a material from NIST or a NIST SRM traceable internal standard. QNMR is a primary ratio method and impurities do not affect the result. After a comprehensive number of tests, from content determination and homogeneity to stability, the CRM is issued in accordance to the ISO 17034-17025 double accreditation with a certificate provided according to ISO Guide 31, including the components that we have been discussed previously, like traceability statement, expiration date, certified value, expanded uncertainties, as well as the required signatures and stamps from the accreditation body. Now let's take a look at the mass balance approach. Like QNMR, the mass balance approach assigns purity content, which represents the true amount of the material by weight. Here we use a comprehensive panel of tests to get a 360-degree view of the molecule. Mass balance is not a simple assay to a similar standard. We perform a full characterization of the molecule, determining the identity by multiple methods and the purity by multiple methods. We perform 2 to 3 chromatographic purity tests with different columns and detectors, like LC and GC, to ensure we are detecting all impurities. For an accurate determination of the mass fraction, no potential impurities can be ignored. So beside the chromatographic purity, the water content, residue solvents, and inorganic impurities are measured. Each technique includes its own validated method for carrying out one part of the full characterization. The formula below shows how all the results from the different testing techniques are taken together to generate the purity factor for assigning the content or potency value. As mentioned previously, traceability is an important quality requirement for a certified reference material. Traceability for mass balance is achieved through each of the individual component tests. Mass measurement in each component test is traceable through balance calibrations to an SI unit of mass, in this case the kilogram. Other components are traceable through instrument calibrations and system suitability tests using higher order standards. On this slide, we have mass balance certification examples on a variety of natural product neat materials. Many of these compounds are difficult to isolate, purify, and stabilize. As you can see, chromatographic purity alone is not adequate to assign a total content. In the case of catechin 3 gallate, the material has residual solvent and water as well as trace inorganic content, some of it as hydrate and some from the process of isolation and purification. These residual impurities must be quantified and accounted for in use of the material, even though these would not be seen by HPLC or GC. For laboratories preparing their own in-house working standards, significant error may be introduced in quantitative uses of the reference material without full characterization of the neat material. So this concludes the technical part of my presentation. Let's now look at the reference materials for food and beverage testing. Food testing is clearly on the rise and projected to grow at an average annual growth rate of more than 6% in the coming years. So who are the players in food testing and what factors are driving food testing? Well, there's a lot of media coverage of food scandals, incident of food fraud, mislabeling or adulteration. Academic research groups are contributing in discovering such incidents. Consumer awareness of food safety issues are leading to political pressure and therefore to the establishment of new regulations and a stricter enforcement by international bodies like ISO or EFSA and national authorities like the FDA. The food industry itself also has a big interest to avoid food scandals, to avoid reputation damage. Other factors are emerging contaminants, for example due to climate change, new food trends like insects or cultured meat, and new increasingly sensitive analytical techniques. All these factors drive an increase in food testing, and as we learned in the first slide, reliable test results require reliable reference materials. Our portfolio comprises more than 20,000 certified reference materials and analytical standards. But how can you find the one you need? You could, for example, use the search function on the Sigma-Aldrich.com webpage. After entering your search term, you can then refine your search results by choosing the quality grade or the format of your need on the left-hand column. Another possibility is to browse our product categories on the reference materials main page, Sigma-Aldrich.com standards. A tip here, when you click on one of these categories and then on one of the subcategories, you can again refine your choice by defining quality grade or formats. To make it even more easy for you, we also set up some segment-specific pages for food, pharma, and environmental testing. Here you will quickly find the relevant product groups and subpages for the corresponding testing segments. Let's have a look at the food segment page. The most relevant product categories are here organized in 9 tiles. The first group is representing our microbiology CRMs. This range consists of more than 100 hydrosoluble discs with certified CFU levels for the most common bacteria and microorganisms under the brands Vitroids and Lenticules. The second group is pesticides, where we have a very comprehensive portfolio of more than 1,400 certified reference materials and analytical standards grade. The latter under the well-known Pestanal brand. Biotoxins are including mycotoxins, marine toxins, cyanotoxins or alkaloids. The portfolio of veterinary drugs includes antibiotics and hormone CRMs and standards of the brand Veterinal. The tab Food Identity Testing combines some niche product lines, for example DNA standards for animal and fish identity testing, botanical reference materials, or CRMs for genetically modified organisms. Other contaminants include heavy metals, packaging contaminants, and food dyes. The remaining tabs include physical properties, food matrix materials, and a tab called Food Quality Testing that combines amino acids, lipids, carbohydrates, vitamins, or phytochemicals. We unfortunately don't have time now to discuss all of these product groups in detail, but I would like to highlight 3 product groups of special interest or where we have recently launched exciting new products. These 3 highlight topics are marine toxins, extractables and leachables or food contact materials, and food matrix materials. Here it is highlighted where you can find these on the food segment page. Marine toxins are mainly produced by algae, but they can be very harmful to humans when they accumulate through the food chain. These toxic algae are growing exponentially in so-called algae blooms. It is difficult to predict when and where such algae blooms occur. Furthermore, due to global warming, these can also spread now to areas where they were previously unknown. The development of LC-MS to become increasingly sensitive is causing a shift from older biological assays to LC-MS to test these toxins. Therefore, reliable reference materials are required. But there is a challenge for us reference materials producers. The pure toxins have to be isolated from algae and are mostly only available in very small quantities. So we are using a combined method of quantitative NMR and isotope dilution MS to certify these compounds we call micro-QNMR. A few milligrams are enough to prepare a stock solution. An aliquot of this solution is quantified by quantitative NMR. After that, the stock solution is diluted to the final concentration of the CRM and filled in ampules. The stability tests are then performed by isotope dilution MS. Using this method, we have so far launched 15 CRM solutions. For example, the native form, but also an isotope-labeled CRM of saxitoxin hydrochloride as a representative of the paralytic shellfish toxins, or the more recently added okadaic acid, or groups like brevetoxins and pinatoxins. I am showing only some examples of different product groups here to demonstrate the variety of chemical structures these toxins have. The next highlight group are our reference materials for extractables and leachables or for food contact materials. The term extractables and leachables is mainly in use in the context of pharmaceutical products and medical devices. In the field of food, the more common term used is food contact materials. There are many region or country-specific regulations for food contact materials. These often define what chemicals are allowed to be used to produce materials that come into contact with food. They usually come with a positive list of chemicals, but also defining maximum migration limits for a lot of these. In addition, also the occurrence or formation of non-intentionally added substances has to be controlled. So, extractables and leachables and food contact materials do have a different regulatory background, but a lot of the target analytes are widely overlapping. Still, we are facing thousands of potential contaminants. This means that the analysis is usually not target-specific. A big challenge is that no potential contaminant should be overlooked in the analysis, while there are thousands of potential analytes with very different structures. So for a reference material mix, we would like a broad range of analytes with different physicochemical properties to make sure that the analytical method used is suitable to find a wide range of chemical structures. Also, we wanted to focus on the most commonly found extractables and on the most toxic ones. To develop these products, our internal colleagues from the Extractables and Leachables Lab from the Central Analytical Services in Darmstadt helped us to define the most useful combination of analytes for reference materials they would also use internally. Based on this collaboration, we launched two first screening mixes for extractables and leachables, one with chemicals typical for LC and another one for GC extractable studies. You can find these products under the URL given here. The last product group I would like to focus on is food matrix materials. These are real-life samples of different matrices certified for the content of certain analytes, such as mycotoxins in wine or heavy metals in milk powder, or there are countless combinations actually. These materials can be used to develop or validate analytical methods, including the sample preparation step, to correct for matrix effects. To make it easier to find a suitable product among the more than 200 food matrix reference materials in our offering, on our webpage you will find the products listed by analyte type or by matrix type. So if, for example, you are interested in materials for fish and seafood, you can easily find all the related matrix materials that are available. One very interesting new addition is a range of food matrix materials certified for elemental content of carbon, nitrogen, hydrogen and sulfur, or for isotope ratio. These products are very well suited to verify your results in elemental analysis or isotope ratio in food matrices to potentially detect food fraud or adulteration. We are planning to further expand our offering for food matrix materials and offer a bigger variety of matrix analyte combinations. For this, we would appreciate the input from our customers so we can be focusing on the products that are most needed by you. So if you could take 5 to 10 minutes and fill out a little survey on our webpage, this would be very helpful for us. Thanks a lot. So I have been talking now all the time just about reference materials, since this is of course the topic of this webinar. But at last I also would like to point out that our company is offering all consumables that you will need in your analytical workflow under the Sopelco brand, from sample preparation products like SPE over to solvents, analytical reagents, TLC plates or chromatographic columns. If you would like to be kept up to date about new product additions, regulations, or a lot of useful applications, I would like to recommend you to subscribe to our Analytics Reporter magazine, which is issued about 4 times a year, and you can get either printed or also as an online version by email. So please visit our webpage at sigma-aldrich.com/analytics to subscribe. With that, I have reached the end of my presentation. I would like to say a big thank you to the organizers of this event. And of course, I thank you all for your interest and your attention. Thank you very much.
And thank you, Dr. Nold, for that informative presentation. And we will now start the Q&A portion of the webinar. Remember, if you have any questions you'd like to ask, please do so now. Just click on that Ask a Question box located at the far left of your screen. So let's get started. It looks like we have some incoming questions already from our audience members. Dr. Nold, which is the better certification method, quantitative, NMR, or mass balance?
Yeah, that's not such an easy question to answer. I would actually consider both to be equivalent in terms of accuracy and traceability of the results. Of course, both of these methods have their advantages and maybe disadvantages. For example, what I like particularly about QNMR is that the compound of interest is directly tested, while it's indirectly for the mass balance. On the other hand, mass balance also provides a full panorama, a full view of the whole material, including all the impurities. So I couldn't say which one is better. We are using both of these. Both methods are also really valid methods.
Thank you, Dr. Nold. And you mentioned that you are working on expanding the offering for food matrix materials. Are there any new product launches planned soon?
Yeah, actually, we have quite a big pipeline for new products for food matrix material. We are collaborating with Papas in the UK, and we are about to launch 41 new products for various matrices and analytes from them. And then we have another 37 new products in pipeline that should be launched soon that are manufactured by the company Trilogy. And these are mainly mycotoxins in various different matrices. And then we also have some projects to develop internally matrix materials in collaboration with the Swiss Metrological Institute. So you see that a lot is going on, and you are going to see this portfolio growing over the next few months.
Wonderful, thank you. And again, thank you, audience members, for your questions today. We have one more question. Are you offering all the 3 quality grades, CRM, RM, and analytical standard for any given analyte?
No, that would not be actually feasible. So It really depends. Of course, if there are so many potential analytes, of course, for an analyte which is very important, very often used, like, for example, ascorbic acid, you will find different quality levels available. But for more, let's say, niche compounds that are not so often tested, usually it's not economically feasible to do the certification to CRM. So then there's only an analytical standards grade available. But also there might be other examples like the marine toxins, where the material is very expensive, the starting material. So actually the cost difference isn't even so high between an analytical standard and the CRM grade. So there it wouldn't make sense to offer an analytical standard and we only have the CRM. So you can see it really depends on which compound it is, but we cannot offer all the quality grades for all the products.
Dr. Nold, thank you again for your time today and for your important research. And before we go, I want to thank the audience for joining us today and for their interesting questions. Questions that we did not have time for today and those submitted during the on-demand period will be addressed by our speaker via contact information you provide at the time of registration. And I also want to thank our sponsor, Millipore Sigma, for today's webinar. This webcast can be viewed on demand through June of 2021. Until next time, take care, be safe. Bye-bye now.